This is Christopher Sernaque hosting episode 19 of season 5 of the Current Topics in Science podcast. This podcast will address breaking scientific news in light of the origins debate and host interviews with scientists. Today we'll be talking with Dr. Brian Miller about the origin of life and the debate Dr. Tour had on whether or not we are clueless about life's origin. This podcast is available on the following platforms: iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Video recordings of the podcast will be uploaded to YouTube. Enjoy the podcast. Today on Current Topics in Science, we have the honor of hosting Dr. Brian Miller. Dr. Miller obtained a Bachelor of Science degree in physics with a minor in engineering from MIT, a PhD in complex systems physics from Duke University, and is an expert in the physics of thermodynamics and information theory. Dr. Miller is the research coordinator for the Center for Science and Culture at the Discovery Institute, helps to manage the ID 3.0 research program, and was the primary organizer of the Conference on Engineering and the Life Sciences. He also has consulted on organizational development and strategic planning, and he's a founding member of an innovation consortium that developed into The Startup, a virtual incubator dedicated to bringing innovation to the marketplace. He's contributed to multiple books and technical journals covering the debate over intelligent design, including The Mystery of Life's Origin, The Continuing Controversy, The Comprehensive Guide to Science and Faith, and Inference Review. He's a regular contributor to Evolution News and Science Today and the ID The Future podcast. And now, without further ado, good afternoon, Dr. Miller. How was your day and how are you doing?
It's going very well, and it's really a pleasure to be back.
It's always an honor to have you on Current Topics in Science, Dr. Miller. And since this is Current Topics in Science, let's quickly look at this week's current topic. This is an article from News Medical and Life Sciences called New Insights into How Amino Acids Shape the Genetic Code of Ancient Microorganisms. The article begins by saying, and I quote, "By simulating early Earth conditions in the lab, researchers have found that without specific amino acids, ancient proteins would not have known how to evolve into anything alive on the planet today, including plants, animals, and humans. In other words, life thrived on Earth not just because some amino acids were available and easy to make in ancient habitats, but because some of them were especially good at helping proteins adopt specific shapes to perform crucial function." The article then quotes Stephen Fried, a Johns Hopkins chemist, saying, "Protein folding was basically allowing us to do evolution before there was even life on our planet. You could have evolution before you had biology. You could have natural selection for the chemicals that are useful for life even before there was DNA." Dr. Miller, what do you think of this current topic? Is it possible for evolution and natural selection to occur before the origin of life?
No, what that article says doesn't really make a lot of sense. And the problem is, origin of life researchers recognize that when you look at life, you see evidence of design, purpose, coordination. Yet they're not willing to acknowledge that there's a designer. So what they've done is they've imparted godlike properties to nature. So you hear all the time things like nature selects, or the amino acid knows, or proteins know. But that doesn't make any sense whatsoever. In fact, I want to read a quote from the paper that popular article was referring to. And it was referring to actually this journal article called "Early Selection of the Amino Acid Alphabet Was Adaptively Shaped by Biophysical Constraints of Foldability." Now I'm going to read you a quote and then explain it. It says, "The outcome of our study showed that an inclusion of some of the most feasible alternatives, and that's alternative amino acids in a protein that are different from the amino acids we see now, would not have supported the twin properties of rich secondary structure, potential, and solubility. Hence, our study demonstrates that the biophysical requirement of foldability, by which we mean the ability to fold into a soluble defined conformation, provided a selective pressure shaping the building block selection in the early alphabet and therefore explains why certain early amino acids and not others were selected to construct proteins. Now, what they're saying essentially is that if you look at the amino acids we have in modern proteins, and there's 20 amino acids which are most common in proteins, and there's a few others in rare occasions. And what happens, those amino acids have very special properties that allow for the folding of these sequences into three-dimensional shapes to produce enzymes or structures in proteins. And these very special amino acids have what are called side chains, and those are basically sets of atoms that perform special tasks. They act like an acid, they act like a base. Some attract water, some repel water. So what these authors are saying is that if you had, let's say, different amino acids in your chain, in your protein, it wouldn't do what you needed for life. So they say, therefore, the right amino acids were selected for these protein properties. But that makes no sense. How would nature know that these protein properties would be useful for a cell much further in the future? Because the problem is to have so-called natural selection, and the term isn't even a good term because nature doesn't select, but to have anything that they call natural selection, you've got to have something that reproduces, that conveys information from one generation to the other. And then what happens is when it reproduces, you have small changes, and then those small changes result in one version reproducing more than another version. But these proteins don't self-replicate. So this invoking of selection is one of those sort of bait and switches. It's like we see evidence of purpose and design. We don't want to acknowledge it, so we'll just invoke the term natural selection, almost like a demiurge, to give godlike properties to nature. That's what's happening here.
Thank you for covering that, Dr. Miller. And along those same lines, you wrote a critique of the RNA world hypothesis in your article called Professor Dave, in his debate with James Tour, showcases the art of citation bluffing. You wrote, the smallest RNA that could possibly self-replicate is around 200 nucleotides. The challenge is that the number of possible nucleotide sequences that long is over 10,120. And the percentage of sequences that could perform self-replication must be minuscule. Benner acknowledged in his article, Paradoxes in the Origin of Life, that sufficient RNA could never have formed for even one to have the correct information to self-replicate. The RNA world hypothesis is a non-starter. Dr. Miller, why is the percentage of sequences that can perform self-replications minuscule? What drives it to be so?
That's a great question. So what happens is that the whole RNA world hypothesis assumes that you have these long chains of nucleotides that come together, then they can fold into interesting three-dimensional structures, and they can act like proteins. They can act like enzymes. So the idea is that early life didn't need proteins because it had these what are called ribozymes, which again are like RNA enzymes. And what happens is in this RNA world scenario, some of these can replicate other RNAs. So you've got these RNAs that are duplicating themselves and they're duplicating other RNAs. So you get this evolutionary process to take place. That's the logic. But there's major problems with that. And before we even get to the issue of self-replication, you have to ask, did you actually have RNAs on the early Earth, RNA molecules? And the answer is you didn't, at least not in abundance. Because if you look at any experiment to produce ribose, and ribose is the sugar that's used in RNA. So an RNA molecule includes nucleotides, and nucleotides have the ribose sugar, a phosphate, and then what's called a nuclear base, which is what contains the information. And what happens is all the experiments just to produce the sugar produce lots of other molecules. So what that means is that you've got a few ribose molecules in a sea of other molecules. And to get one nucleotide, that ribose has to somehow find a phosphate and then find a nucleobase. So what happened is the nucleotides would be in extraordinarily small concentrations. And they'd be surrounded by so many other molecules that you're never going to see a bunch of nucleotides form into a very long chain. Huge problem. But let's ignore that problem. Let's not worry about it. Let's imagine that you had aliens that dropped just millions of tons of randomly sequenced RNA on the early Earth just to help things out. Well, the problem is, as I mentioned, there's going to be there's 4 separate nucleotides in RNA, And if you've got a chain, which is, let's say, 200 amino acids long, nucleotides long, that means that you've got 4 to the power of 200 possible combinations, which again, I believe I said was 10 to 100 to the power of 120. That's a lot of numbers. And the problem is, most of these chains aren't going to do anything interesting. If you were to randomly select chains that did something, you'd find that like roughly one in several trillion, I believe it's like 100 trillion, would do something like merge 2 RNAs together, something simple like that. But to have something that can self-replicate, that's hard. That's a really hard function, because what you have to do is take a template strand, a strand of RNA, and then you've got to match up every nucleotide with its partner, its complementary nucleotide. So for instance, you've got to have A with U, you've got to have C with G. So, and then you have to do that with high efficiency. So the chances of that forming are fantastically small. And that's not just my opinion. You quoted my quote of Stephen Benner, and he said in his article, talking about the paradoxes of the origin of life, that even implausibly high concentrations of nucleotides would never form enough chains for one of those chains to have the information to do something interesting. That's a big problem. He recognizes that, but it's even worse, because even if you imagine my alien scenario, what happens is a random nucleotide chain that breaks apart other nucleotide chains is much, much, much easier than a nucleotide chain that like would copy other nucleotides or did anything interesting. So even in my alien scenario, what happened is that the RNAs that broke things apart would simply snip all the RNAs until there was nothing left and everything just decomposed into simple molecules. So that's the big problem.
Dr. Miller, thank you for explaining that. And continuing with your commentary on the debate, in your article, "Hello, Professor Dave. James Tour's criticism of origin of life research echo those of other experts," you wrote, and I quote, "Life does not represent an emergent property of matter, but a system of processes directed by advanced nanotechnology to operate in conformity with a blueprint or design architecture. One could no more explain the organization of a cell through the chemistry and physics of its constituent molecules than one could explain the origin of a car through the chemistry and physics of metal, glass, rubber, and gasoline." So, Dr. Miller, can you tell us, why is it the case that life is not an emergent property of matter?
That's really the key question. And this is a problem that many people have when they address this question of the origin of life, because they sort of assume there must have been these self-organizational processes that help to bring molecules together to form different cellular components. The problem with that argument is that just is not consistent with the nature of life. Life is like technology, in that what you have in life is advanced machinery. You've got energy production, you've got information processing, and all that advanced machinery results from molecules, which again are like the proteins, where you have amino acid chains, or DNA or something like that. And you have to have a very specific arrangement of amino acids for this protein to fold into the right three-dimensional shape. And what happens is in those proteins, these what are called, which often are enzymes, will force the right chemical reactions to take place. They'll cause molecules to come together into the right arrangements for machines like ATP synthase or a ribosome. So what happens is almost nothing in life is a direct consequence of the physical properties or the chemical properties of the individual molecules. What happens, and people like Michael Russell have talked about this, in one of the links below this interview is my article that you quoted from. And I linked to one of Michael Russell's articles. He talks about this very point. He talks about how nothing in life happens arbitrarily, because normal chemistry and physics would cause a lot of things to happen that's not useful to life. Instead, machinery forces everything to happen that needs to happen. And then he uses the words that this all must conform to an elaborate organizational design. It's like the car. So what happens is a car works because an engineer said, I need an engine, I need a steering wheel, I need a chassis. I have to have like a drive chain and things like that. And that blueprint is what determined how the materials were put together to conform to that organizational design to achieve a purpose. In the same way, Everything in the cell happens because there's an organizational design, there's a blueprint, and you've got machinery that forces reactions and processes to take place according to that blueprint. You've got other machinery that builds machines according to that blueprint. So if you look at any molecular machine in a cell, it transcends the physics and chemistry of the parts. It's because that blueprint directed the formation of that machine. That's the problem. So it can't be the process of some self-organizational process or an emergent property of matter. Because what happens is natural processes, self-organizational processes, are always doing what nature normally does. They take reactions to lower free energy. It's whatever the least difficult path is. But virtually everything in life would not take place without machines making it take place. So any self-organizational process would destroy a cell. It would not build a cell or sustain a cell.
Before we go, Dr. Miller, I'd like to review an article that you wrote about the top 5 evidences for the scientific theory of intelligent design. Mathematician, and I believe I'm pronouncing this correctly, Granville Sewell, summarized the 5 evidences as follows: the fine-tuning of conditions on Earth, the fine-tuning of the physical laws of our universe, the origin of life, the origin of intelligent humans, and the origin of human consciousness. So with these 5 evidences in mind, Dr. Miller, for a moment pretend that I am a scientist who has rejected the scientific theory of intelligent design. Out of these 5 pieces of evidence, which one would you share with me to change my mind, and how would you build your case?
What I would do is try to understand the philosophical framework of the person I was talking with, because what happens is the strongest evidence of design is associated with life. That's where it's really clear. You see the same engineering principles humans use in life, but they're only done at a much more sophisticated level and in a way that's much more clever. The problem is there's a lot of emotional baggage that comes along with the idea that life is designed. In fact, part of what happens is when you go to a science class or when you listen to the media or when you watch TV, even often movies, is there's a certain narrative about reality, a certain worldview. And that worldview is that life is the product of blind, undirected processes. And the message you always hear is anyone that says they see evidence of design is just a religious fanatic. They're just anti-scientific. They're bad people. They want to impose a theocracy on you. They're bad people. Don't be a bad person. So there's so much emotional baggage with the issue of design in life that often I'll start with the laws of physics because that's a much less heated topic. And even mainstream scientists in the mainstream literature talk about how the laws of nature seem to have very, very special properties to allow for life. People like Luke Barnes has written about this in beautiful ways, and he's cited many, many cosmologists that acknowledge there's this fine-tuning. Now, many of them are atheist or agnostic, so they're not willing to acknowledge that that design is real, that the fine-tuning points to a designer. So they'll appeal to things like multiverses, but all of those appeals reference theories that also have to be fine-tuned, so you really can't escape it. So often that's a very neutral way to start the conversation. Also, I'll talk about the origin of the universe. That if the universe started, that time, space, matter, and energy all began, that means that there was a designer outside of time and space that started the universe. Now, if that was something that they accepted, if that made sense to them, then what I might do is sort of feel my way into the origin of life. Because even the origin of life isn't as much of a hot button issue as like human evolution. So I would talk about the various evidences of design, why it can't happen thermodynamically. And then if they still were open to that possibility, I would then go into the design of advanced biology, like the human mind. So the human mind is extraordinary because it has, hundreds of trillions of connections. It operates with an efficiency far, far greater than human computers. Because if our neural connections and our chemical signals operated with the same efficiency of human engineering, then our brain would just burn up pretty quickly. So you're seeing incredible sophistication. You've got neural networks. And that's something that could not have happened by chance. In fact, if you look at evolution and look at how fast evolution can take place, like you look at the paper like by Durrett and Schmidt, which I think was around 2008 plus or minus, maybe it was 2004, but whenever it was written, they talk about how if you look at how long it takes for specific mutations that are coordinated, meaning that you need both for an advantage, to appear in our theoretical ancestors, it's like 100 million years for 2 mutations. Well, that's a long time. Now, if you want to evolve something like vocalization, where we can hear sounds and then repeat them, well, that's going to require a whole lot of neural connections that really travel through a good distance across your brain. Even one targeted neural connection is going to take a lot more than 2 mutations. So, from a mathematical perspective, it's very clear that the human brain did not evolve through blind, undirected processes. In fact, if you look at all mutations that have taken place in humans in the last century and a half, the number of humans that are alive today in the last century are comparable to the number of humans ancestors that were believed to evolve from an ape-like ancestor. Yet we've not seen one mutation in modern humans that would enhance any neural connection, that would add a new neural connection that would enhance some ability. We've seen known mutations in the neurons of, let's say, mice or rats or fish that would in some significant way add some advantage, that would create some new capacity. So from the evidence of mutations, the mutations that are needed to create some large-scale change in a brain never occur. That's a huge problem. And then if you look at studies like studies of neural networks behind things like vocalization, it's very, very clear that they need planning, they need coordination. You can't just put a random neural network together and expect it to do something. That you've got to have a lot of very targeted chains. So at every level, when you look at things like human consciousness or vocalization or anything along those lines, you see indisputable evidence of purpose, coordination, goal direction, and it's implausible mathematically for that to have happened through some blind undirected process. So that would be the process I would use. I would start with the origin of the universe, fine-tuning the laws of nature, go to origin of life, and then go to advanced animals or plants, and end with human brain, the human consciousness. That's the way it would work.
Dr. Miller, we've now arrived at our final question. And while Discovery Institute is not a Christian ministry, and people of a variety of backgrounds both work for and support Discovery Institute, I know from my personal encounters with you that you are a Christian. That's why I'd like to share this text with you. The Bible says, "I've gone astray like a lost sheep. Seek your servant, for I do not forget your commandments." Dr. Miller, for somebody who has lost their way, how can they come back to God?
When I was in college, I was pretty naive to the challenges I'd face. And I faced people that said the Bible was a bunch of nonsense. They said that all the evidence points to the fact that we're just a blind, undirected product of nature, and many questions like that. I became pretty convinced for a while that Christianity was just a psychological crutch. I thought people that believed in God, that had faith, were just not necessarily thinking carefully. They didn't know science. They weren't really being honest with themselves. So I said, God, I don't know if you exist. And I knew if he didn't exist, that would be bad, because then I'd die and cease to exist. Didn't matter how happy or sad I was. Eventually I would die. The planet would explode when the sun exploded. So it's pretty bleak. And I said, God, I don't know if you exist, but if you do exist, you have to prove it to me, because I'm a scientist. I just can't do this on blind faith. And I said, if you are real and you prove it to me, I will serve you with all of my heart. And what happened was God intervened in my life, and he brought me to the right people at the right time that helped me to see that the evidence of science points to a creator. To see the evidence behind the resurrection is pretty overwhelming. The evidence that the New Testament represents really good history is very strong. But also that I encountered God supernaturally. I saw extraordinary answers to prayer, miraculous healings, experienced God's love and presence in some pretty remarkable ways. And that really brought me back to faith. So my encouragement to you, who may be in that place, is that the separation between us and God is not an intellectual separation, it's a separation of the will. It's, are we willing to surrender our lives to serve him? If he is real, are we willing to respond in a way that would be consistent with that reality? And if that is the case, and you ask God's help, he will help you. He helped me. And then you can go on that journey. And at Discovery Institute, we've got a lot of resources for the evidence of design in nature. There's other groups that have that also. There's wonderful books about the resurrection. So the information is out there. But the key point is for you to decide, are you going to surrender your life to him? Because if you're willing to serve God, he will speak to you in different ways. He will help you along that journey. So that's my encouragement to you, is just be willing to surrender your life to him. And that's the life of significance that you're meant to live.
Dr. Miller, thank you very much for your time. It was an absolute joy. And to our listeners, Thank you very much for taking the time to learn with us on current topics in science, where scientific discoveries are examined in light of the origins issue. You can find Dr. Miller's biographical information, credentials, and written works in the description. You'll also find links to his numerous video lectures and a link to the Christ Jesus Ministries merch store. Please share and subscribe to the Current Topics in Science podcast. It's available on iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Thanks again for listening. And remember, the truth saves.